Hey, it's Dr. J. I'm back with the second part of 2.3, the linear modeling section. These are a few examples that didn't make it on the first part of the video. I had to stop the video a little bit early, so I'm back to finish the video. We're going to talk a little bit about temperature. I know we talked about it last time. Today we're going to talk about Celsius, Celsius versus Fahrenheit. We're going to talk about how to get back and forth, to convert back and forth between degrees Celsius and degrees Fahrenheit. This symbol here is what we call the degree symbol. Okay. We're also going to learn a little bit about money, revenue, cost, and profit. Yeah, so these are the money problems. And then we're going to talk, we have one example about cell phone plans. Although they don't have to be cell phone plans, they could be just any type of monthly bill. In particular, your cell phone, but it could also be applied to other things that you're charged monthly or daily or weekly or whatever. So other types of models that involve, a subscription or a plan that you have to pay for over time. Okay. In particular, we're going to talk about cell phones today. So these are the three types of examples that I did not have time to cover in the last part of the lecture. So let's go ahead and get started. We'll talk a little bit about temperature today. So I often get the question from students, and not just students, but people in general. And I talk to relatives or friends or something, and people find out I'm a math teacher. One of the first questions I get is, "Oh, you're a math teacher? What's math good for? What are you going to use it for? What are you going to do with all these formulas that you learned?" And I want to be totally honest with you, not much, right? I mean, most of us, you learn math, you take your math class, you pass your class, and then you just go on with your life, and you probably won't use it very often. But there are some exceptions. In this lecture today, I'm teaching you some very practical things that you might actually use in your life. One of them is temperature. It's something we have to deal with all the time. How hot is it? How cold is it? Unless you really don't care. But, especially here in the desert, I kind of care. I want to know how hot it's going to be. And money. Yeah. Time and money. Those are the things. Temperature, time, and money. Those are three things that everybody has to deal with. And so recently on a trip, so I'll say this is example one, I guess. Might as well start numbering. On a trip to Mexico. So most of the world uses Celsius. The TV news, I was watching the morning news, in the hotel before I went out about my day. The TV news said it was going to be 35 degrees Celsius today. So it's just giving you the morning news, just like we have here, Good Morning Mexico. And, it's going to be 35 degrees today. It's going to be hot. They said it was going to be hot. And I said, wow, it's going to be hot? 35 degrees? I don't know about you, but I live in Palm Springs. 35 degrees is not hot. Yeah. But this is 35 degrees Celsius. Most of the world, excluding the United States, most of the world uses Celsius. Canada, Mexico, almost all of South America, Europe, Asia, Africa, most of the countries. There's one or two countries in Africa that still use Fahrenheit. I'll leave that to you as a curiosity fact, or curiosity quest, if you want to go out there and figure out what countries still use Fahrenheit. You're going to find that it's a very, very small list. So if you travel around the world, or if you leave the United States, chances are you will see temperature listed in Celsius. I want you to convert this to Fahrenheit. Degrees F, Fahrenheit. All right, so how do I do that? How do I figure out what is 35 degrees Celsius if you convert it to Fahrenheit? Now, if you're a world traveler, if you do this a lot, you probably do it with mental math. It's kind of like converting your dollars to pesos or whatever, to euros or wherever you happen to be traveling. And you might know how to do it because you do it all the time. But if you don't do it all the time and somebody just asks you a question out of the blue like that, you might not know precisely how to do it. So that's what a linear model is for. Okay? So what I remembered, I couldn't remember the exact formula, but I do remember from high school. For those of you that don't know me, I'm from the desert here. I went to Palm Springs High School in 1986. Okay, so that gives you a little bit of a clue as to about how old I am. So in Palm Springs High School back in 1986, I took a class called Home Economics. And in home economics, we mostly cooked. Yeah, we learned a lot of recipes and how to cook. And I learned that water freezes at 0 degrees Celsius and 32 degrees Fahrenheit. So I remembered that there was an equivalency there, that these numbers were equivalent. 0 Celsius is freezing, which is 32 Fahrenheit. And boils, you can boil water at 212 degrees Fahrenheit, which is equal to 100 degrees Celsius. So thank goodness for home economics class from Palm Springs High School in 1986, because I also took college physics and college astronomy in which they teach you some fancy formula on how to do it, and I just couldn't remember. I couldn't remember the formula from college, but I could remember the brownies we made in home economics and boiling water. 0 is 32 and 100 is 212. So that's about it. That's about all I have in my brain. And here I am trying to solve this problem. How hot is 35 degrees Celsius? Using only these given values here. And so linear modeling. All right, as long as something is linear, which most things at this point in our class are all linear, you can draw a graph. Okay. Now you have to make a choice as to which one is going to be your x and which one's going to be y. I'm going to let C be x. That's my Celsius. Once you make up your mind, that's it. Now you're stuck with that. And then I'm going to let F be the y. So F is going to act like the y. That's our ordinate. And C is going to be our abscissa. Now, why did I choose it that way? Because X is on the left and Y is on the right. I honestly did it that way for simplicity. It just seemed easier. And by the way, if you do it the other way, you will still get a same answer. It might look different, but it would be an equivalent result. Okay. And then I just plotted these as points. Yeah. So if X is 0, yeah, so this is my X1, which is 0. Y is 32. So this is the point 0, 32. Yeah? X and Y. Okay. And then I go a little bit down the axis here to 100 degrees Celsius. I'm going to go ahead and omit the symbol for degrees and just say 100. All right. And then up here on my f-axis, it's 212. So I have a point over here where x is 100 and y is 212. All right. So if you don't know how to solve a problem, draw a picture. Sometimes the picture will guide you into the problem. You don't just have to snap out an equation in your head. You can draw a picture and let the equation come to you. All right? You might see it now, right? You see it? Slope-intercept form, yeah? So we're going to use slope-intercept form. Okay. Now I'm going to dress it up a little bit different. My y is Fahrenheit, and my x is Celsius. So it's going to be F equals MC plus B. And remember what we learned before about B being free? Remember I called that a freebie? Yeah. So there's your B right there. B is the y coordinate of the intercept. Yeah. So it's 0, comma B. That's always going to be your B. I'll put the B above the 32 there. So the y-intercept is always 0, comma B. That's an always rule. You get that one for free. Okay? That's the only one you're going to get for free. All right? M is going to be the rise over the run. Okay? So how far is it rising? It's going from 32 to 212. So the rise is 212 minus 32. So the rise is 180. 212 minus 32 is 180. So the rise over run, rise is going to be 180. The run, horizontal run, from 0 to 100, you could probably just do that in your head. The run from 0 to 100 is 100 minus 0, which is 100. So there's your M, 180 over 100. You should simplify this if possible. Let's go ahead and do that now before we get too far ahead of ourselves. So that'll be 18 over 10. Yeah, they're both divisible by 10. And then they're also both divisible by 2. So 18 divided by 2 is 9. 10 divided by 2 is 5. So that'll be 9/5. So there's your slope. So I've got my formula. F equals 9/5. That's my M. My X is C. And then plus my freebie. My freebie is 32. And so that is your linear model. And there you go. So Fahrenheit is equal to 9/5 times the Celsius plus 32. Remember my question? My question was 35 degrees Celsius. That was what I was trying to figure out. So I'm going to plug in my 35 degrees Celsius, and this formula will automatically tell me what the Fahrenheit is. Just replace the C with 35. 5 goes into 35 7 times. So that becomes 9 times 7. Make sure it's 9 times 7 and not 9 divided by 7. Notice the way I wrote it was kind of sloppy. So you got to be careful if you write sloppy. 9 times 7 is 63. 63 plus 32 is 95. And so the answer is 35 degrees Celsius converts to 95 degrees Fahrenheit. Okay. And so now you could just memorize this formula, and then whenever you travel around the world, you can use it. The sciencey way to do it, if you take a science class, they write it this way, 1.8. That's the decimal version. I prefer 9/5 because you don't need to use a calculator with 9/5. If you don't mind using a calculator, you probably will have your phone with you if you're traveling. You could just do 1.8. Okay. So there you go. That's how you convert. Example 2. convert 108 degrees Fahrenheit into Celsius. I picked 108 because I think that was the temperature today in Palm Springs. It might have been yesterday, but it's been pretty hot lately. So that's like a current desert temperature. So let's turn it around the other way. Somebody from Canada comes down here to visit the United States, or somebody from Mexico, or somebody from Europe, or darn near anywhere else on earth. They come to the United States, they check into their hotel in Palm Springs or Palm Desert, and it says, it's going to be 108 degrees today, and they freak out, oh my God, 108 degrees. You know, how hot is that? Well, in order for them to really, truly understand it, you know, if you've grown up your whole life learning Celsius, you would want to use this formula. So this time I'm giving you the Fahrenheit. So you're going to plug into the F and solve for C. So you're just basically going to reverse this process by plugging in F and figuring out what C is. If you want to reflect back on the problem that we just did, this is what you would get. What you're about to see is what you would get if you were to choose your X's and Y's inversely, right? If you would have chose X to be Fahrenheit and Y to be Celsius. So I'm sort of reversing the roles here. So I'm just going to omit the degree symbol and just call this 108 Fahrenheit. I know that that means Fahrenheit. And I'm going to solve this in reverse. So I'm going to get my 32 onto the other side. So subtract 32. What's 108 minus 32? Oh, man, that's 76. My brain hurts. I've been doing this all day. 108. I'm going to feel stupid when it's wrong. Yeah, it's 76. I should have just trusted my instinct. 9/5 Celsius. Okay. And now the LCD is 5. So I'm going to multiply both sides by 5. My brain really does hurt now. I'm 76 times 5, 380 equals 9C. And then divide both sides by 9. 42.2. It's technically 2 forever and ever. I'm going to go ahead and round to the 10th. So that'll be 42.2 degrees Celsius. And that would be 108 degrees Fahrenheit. There you go. An interesting fun fact, if you travel to Europe, most thermometers in Europe, not all, but most of them stop at 40. Yeah. So it just never gets that hot in Europe, you know. And so you go to a public thermometer, sometimes they'll have these outdoor thermometers, and it only goes up to 40. So this is literally blown up the thermometer in most parts of the world. Although here it's a very common temperature. In fact, it'll probably be higher than that today or tomorrow. Depends what day you're watching this video, I guess. Okay, so that's about it for temperature. I'm not really going to make a big deal about it. I mean, yeah, it might be on the test or the quiz, but I just want you to have a basic understanding of how temperature works, and I want you to be able to translate back and forth between Celsius and Fahrenheit. If you do it a few times, you get pretty good at it. It's not that bad. Okay. We better move on to the next type of question, which would be the business math. Another funny story. When I was younger, before I started my career as a math professor, I tried several small business enterprises, selling various types of merchandise, t-shirts, hats, stickers. I was in the music business for a few years, selling CDs and cassettes and things like that, and trying to actually make a living or make enough money to get by selling objects. Yeah. So in business math, we let X be the number of objects or items that you are selling or buying or that you are considering in the business, sold or produced by the company. Now, this is basic business math, very basic, so it's only one thing. Imagine you have a company that only sells one thing, all right? It turns out that if you want to run a business that sells multiple different types of items, then you need to have lots of different formulas for all the different items. We're being very singular here, very narrow. It's a linear equation, so we're only going to sell one thing, all right? We often refer to these as widgets. Business math, X represents just a widget. A widget is a make-believe fictitious item. And the whole idea is it doesn't really matter whether a widget is a hat or a pair of glasses or a pen or, a book or a computer or whatever. A widget is a thing. A thing is what you're selling, and that's what we really want to base our business model on. Okay? So we have revenue. Revenue is the price per widget multiplied by X. Yeah. That's it. That's revenue. Revenue is how much you're selling it for. That's the price multiplied by X. That's how much money you're bringing in. Yeah. Then you have cost. Yeah. If you're selling hats, these hats aren't free. Yeah. You have to produce these hats. So it's the cost to produce each widget multiplied by X. How much does it cost to make one hat? Multiplied by the number of hats you're making. Now, this is kind of like the slope, yeah, times X plus the B. Yeah. Now, revenue doesn't have the plus B part. Only cost has that. And the B is called the fixed cost. Fixed costs are things like electricity, rent, the labor, the people that are working for you. Those you got to pay them, right? Even if you don't sell any hats or sunglasses or books or whatever it is you're selling, you still have to pay the rent. Yeah, think about it. So what's been happening lately with the COVID-19? You got a business, downtown business, and they still have to pay their rent even if they're closed. Even if your landlord's not going to go, hey, you know what? I understand you don't have any customers, so go ahead and just have free rent for the next 3 months. That's not going to happen. You got to pay your rent no matter what. And then profit. Profit is the money that you actually get to keep at the end of the month. Is revenue minus cost. So we first have to figure out what our revenue and our cost is. Then we can subtract those two and come up with the profit formula. Okay. Let's go ahead and do an example. A company sells widgets for $12 each. Each widget costs $4 to produce, plus an additional $20 per week in fixed costs. And that's actually pretty cheap. $20 a week is pretty cheap. So maybe I just have a very small, what we call overhead. If you're in the business world, your fixed costs are also called your overhead. It's how much you have to pay no matter what. All right. So now this is a weekly model. Find linear models for the weekly revenue, cost, and profit. Now that'll be my objective, to find these models, and then we'll use the models to make the predictions. What would be the profit from selling 30 hats or 30 widgets in 1 week? All right, if I sell 30 of these widgets in 1 week, what would my profit be? Okay, so let's go ahead and just figure out the important information. So we're selling the widgets for $12 each. We're done, right? Revenue is 12 times X. You can omit the time symbol and just say 12X. That's it. Revenue is easy. I mean, as long as you can read and remember what the formula is, it's the cost, the price, the selling price multiplied by X. It's as simple as that. Okay. For the cost function, it's a little bit more because the widgets cost you $4 to make. So that's your slope. Plus an additional $20 in fixed costs, that's your y-intercept. So when you find your linear model is essentially y equals mx plus b. Yeah. We're not using the letter y, though. We're using c for y. All right. You can still use y if you really insist on it, but since it's replacing cost, I'm going to call it C for cost so I remember. We are still keeping XX. So the slope is $4. You can drop the dollar sign times X plus the fixed costs of $20. And you may omit the multiplication sign and just say 4X plus 20. Okay. So there we go. Those are our linear models, revenue and cost. Okay. So what was it? 30 hats. So if we sell 30 widgets, our revenue is 12 times 30, which is $360. Not bad. Whatever these things are, they cost 12 bucks each. The price is $12 each. But remember, you can't keep all $360. You've got to pay for those. So the cost for 30 widgets is $140. Okay, and then the profit is the difference of these two. So the profit, I've run out of space. Profit is equal to revenue minus cost, 360 minus 140 $220. In your homework, you can just type the number. You don't have to worry about the dollar sign. And again, if I were collecting paper, I'm not, but if I were, I would want you to put the dollar sign so that I know that that means dollars. So you get a little bit of a break here on these online problems. So. Okay, so that's basic business math 101. You can't spend all of the revenue. It's not your money, right? Your money is the profit, $220. Make sure you got to pay your rent, $140 a month or $140 a week in I guess that's rent or whatever you want to call it. I don't know who charges $20 a week in rent, but I don't know. I'm trying to be idealistic about this so that you can just understand the concept. So. I do teach a class called Business Calculus. It's called Math 9. I don't know if you realize this, but in math, the smaller the number, the higher the class. So we're now in Math 10. If you're interested, the next class would be Math 9. And that is almost entirely about business math, and it gets a lot more complicated than this. But it starts off like this in the beginning. You start off with some very basic problems like this. So there's my little plug for Math 9. So for more, take Math 9. Okay, we have come to the end, my friends. We have one more example. The next example is finding a linear model for a service that's provided that you pay either monthly, weekly, or daily for. So something like a hotel or a rental car or a cell phone or whatever type of monthly, weekly, or daily service that you might have. In my example, I'm going to do, I'll just call this last example. I don't know where we're at. Now this example is a little bit outdated. I have to update it to the latest data, the latest information. When this problem was first devised, it was the 1990s, and cell phones in the 1990s, I don't know how many of you were born in the 1990s, but they used to charge you by the minute. Yeah, every minute that you were on that cell phone, you were paying for it. Now they charge by the megabyte. So I have updated this problem. Every time it said minute, I changed it to megabytes. So a company charges a flat monthly fee plus an additional charge per megabyte which I'm going to use the letter M for megabytes. I know there's probably a fancier way to say megabytes, but I'm just going to say M. Per megabyte used each month. So I'm assuming it's not an unlimited plan, okay? So they're giving us a few pieces of information. If a customer uses 120 megabytes, actually I changed my mind. I'm going to do MB for megabytes. I want to make sure that I know that that means megabytes. All right. I think it's M capital B or whatever it is, but it's MB. Okay. So if a customer uses 120 megabytes, the bill, the monthly cost is $79. It's supposed to be a dollar sign. Yeah. If they use 770 megabytes, so almost a gigabyte, 1,000 megabytes is a gigabyte, the bill is $306.50. 306.5. Yeah. 0.5 just really means 50 cents. Okay. Find a linear model and then use it to predict the monthly cost if 2,000 megabytes of data are used. Uh, 2,000 megabytes is the same as 2 gigabytes. But I'm going to say 2,000 megabytes. That's the old-fashioned way to say it. All right, so here it is. You know, you got to pay the bills, and this is a revenue problem or a cost problem, all kind of combined together. We call this consumer math now. It's not really business because you're not making any money here. This is consumer math. You are just the customer. The same type of thing works with rental cars. Rental cars often charge you per mile plus an additional charge per day and other things that of that nature. Okay, so let's go ahead and stick with this plan here. So let's go ahead and find our linear model. Our linear model is going to be y equals mx plus b. We have to decide who's independent and who's dependent. Y is cost. X is megabytes, which is, again, the reason why I changed my mind at the last second, and I didn't want to just call this M because I didn't want it to get confused with this M. So oftentimes, to avoid confusion, we change that to an A so it's not confused with megabytes. Oftentimes people will see the letter M and they'll go, oh, M, megabytes, right? In fact, when I say people, I mean myself. I did that myself a minute ago. Oh God, and this is even more confusing because you have an M and a B, okay? So we've got megabytes, cost is dependent. So that's why megabytes are independent, because you are free to use as much data as you want. Nobody's forcing you to use that data. So the megabytes are independent, the cost is dependent. Cost depends on megabytes. So I've got my X1 is 120. My Y1 is 79. My X2 is 770. And my Y2 is $306.50, or you could say 306.5. I'm going to go ahead and make a little savings over here. So I'm going to say X1, 120. I can drop the MB. I can also drop the dollar signs. X2 is 770. Y1 is 79. And Y2 is 306.5. Now I can erase all that. And so we're going to find A. A is the slope. That will be Y2 minus Y1 over X2 minus X1. Getting a little blurry here. Come back to me. Come back to me. That's a little better. All right, so I got 306.5 minus 79 over 770 minus 120. I'm going to go ahead and use a calculator to speed things up a little bit. So I've got 306.5 minus 79, 227.5 divided by 770 minus 120, 650. And now I'm going to divide that. 227.5 divided by 650 is 0.35. That's my A. This is the slope. In a word problem like this, slope means price per unit of data. So we're measuring data in megabytes. So every megabyte is 35 cents. If you want to know intuitively what that means, it means you're paying 35 cents every time you use the phone. Yeah, every time you use a megabyte of data. Okay, so now we're going to do the point slope form. Y minus Y1 equals A. I know it's normally M, but I'm using A. X minus X1. And I'm going to put in my Y1. What was Y1? Y1 was $79. My A is 35 cents. And my X1 was 120. I blew it and I erased it a minute ago, but fortunately I have it written down on paper here. So, and there you go. That's your linear model. I want you to put it into this form. I want you to simplify it into this form. So we're going to work up here. We're going to rewrite it this way. It's relatively simple, although I would probably use a calculator. You get Y minus 79 equals 35 cents times X minus, I can't really do that in my head. I shouldn't say I can't. I should probably say I don't want to. 35 cents times 120 is 42. So now we have Y minus 79. I'm just bringing it all up here, equals 35 cents times X minus $42. And I'm just going to finish this off by adding 79 to both sides. And I get my 35 cents times X plus an additional, what is that? My brain hurts, $37? Yeah. That's a pretty cheap plan, right? I wish my cell phone was that cheap. Let me just double check that. $79 minus $42. Yep, $37 a month. So the 35 cents is per megabyte, and the $37 is per month. This is all cost. There's no revenue here, unless you're actually the company. If you are the company, then this becomes a revenue model, right? I mean, but this is all cost. It's how much does it cost for a megabyte? How much does it cost for a month? And this is your model. So there you go. That's how your cell phone bill works, unless you buy the unlimited plan. I got a lot of people on my cell phone plan. I got a lot of children and big families, so I have the unlimited plan now. But I remember back in the 90s when they didn't have the unlimited plan, and not only was it per megabyte, but it was actually per minute. So now we want to predict the cost for 2,000 megabytes. So we're just going to plug in 2,000. By the time you've paid for 2,000 megabytes, the $37 you're not really going to care all that much about. I think that's 700, but let me just double check. Yep, 35 cents times 2,000 is $700, plus your $37 monthly fee, $737. That's how much your monthly bill is. I would be pissed if I found out that my monthly bill was $737, but that's why you buy the unlimited plan, I guess. Yeah. Okay, that's it. That's it for the word problems. You know, I used to, there was a time in my career where I used to save the word problems, you know, but I don't do that anymore. I give them to you early and often. We'll take a break from word problems in the next module. So this is the end of week 1. Week 1 is done. So if you're watching this video, here's what I recommend doing. Do all the homework, then do the lab. The lab is a practice quiz, okay? So don't do the quiz until you've gotten a good grade on the lab. If you can do the lab as many times as you want. You can practice it over and over and over again. That's why it's called a lab. It's like experimenting, right? Once you feel like you're solid with the lab, then go ahead and do the quiz before Monday, and you only get one chance on the quiz, okay? All right, folks, Dr. Jordan signing out. See you next week on the internet.